All right, moving around the sine and cosine functions. So we're talking about vertical shifts and horizontal shifts. The horizontal shifts, we classify those as phase shifts as we write them out. So when you hear that terminology, phase shift means how far do we move to the left or how far do we move up and down. So illustrated on these graphs, you can see that we have our original sine graph kind of in blue here. It's been moved to the right by attaching a number directly to x on the inside of this function. It's been moved in the red cases graph to the right pi over 4. So what started at the origin has been moved over to the right pi over 4. So it's going to start here at pi over 4, goes up, comes back down before it repeats itself. Now over here we have sine of x minus pi. Again, we're attaching a number directly to x, so that's going to be a left or right movement, a phase shift as we've called it. And this one's being subtracted directly from x, so it's going to move to the right pi units. So from the original that started at the origin, it's been picked up, moved to the right pi units, so it's going to start at pi, goes up, comes back down. Instead of finishing up at 2 pi, this one's going to finish up one more pi to the right, so it finishes up at 3 pi. All right, if we have a vertical shift, what can happen is you're going to be attaching a number to the entire function. So adding or subtracting some number to the end typically. What that's going to do is it's going to pick the entire graph up and either move it up if you're adding a number or move it down if you're subtracting a number. That also moves around our midline, the line that if we drew it in here would go right through the very middle and have equal amount above the midline and below the midline. So on our next one here, you can see sine of x plus 2, that's shifting everything up 2 units. So if I wanted to draw the midline through here, I would probably just start at 2, go straight across here, and you can see that our midline here is going to be at y equals 2. So if you drew that line in there, an equal amount would be above and below that midline. So let's determine the direction and magnitude of these shifts. So on this first one, you can see that we have cosine of x minus 3. So when you attach a number to the entire function, what's happening there is you're moving it vertically. All right, so in this case, we're subtracting a 3 from the entire function. We would say everything has moved down 3 units. All right, nothing else going on here as far as any other shifts. All right, just interpreting this next one, we have 3 cosine of x minus pi over 2. That 3, that's going to affect our amplitude. Just kind of sketch that in here, that affects our amplitude, meaning that it's going to go up to positive 3 and down to negative 3. But then this, the minus pi over 2 attached directly to x, that's going to affect our phase shift. So I'm going to go ahead and say a phase shift in this case because we attached a number directly to x. And remember, that's just moving it to the left or to the right. As we've subtracted a number from x, that's going to actually work kind of counterintuitively. We're going to say that moves everything to the right, pi over 2. So it sort of works the opposite direction you think it should. All right. Next up, we're looking at f of x equals 3 times sine of x with a plus 2 here. That 3 again is going to affect our amplitude. So if we didn't have that plus 2 at the end, this would oscillate between positive 3 and negative 3 for our sine graph. That plus 2, though, that's going to be a vertical shift. That's going to move everything up 2 units. All right, one more of these before we move on to other stuff. We have sine of x plus pi over 6 with a minus 2 at the end. So our amplitude is still 1 because you can visualize there being a 1 out in front here, although we do have a shift in our phase shift. We can say that our phase shift is affected left and right by this plus 6. But remember, it works in the opposite manner as what we think it should. When you add pi over 6, that's actually moving everything to the left, pi over 6. And we also have a vertical shift here, the subtracting 2 from the entire function. We can say that works how we think it should. This has been moved, everything has been picked up and moved down 2 units. All right, so I hope this helps out as you're trying to pick out amplitude changes, phase shifts, and vertical movements either up or down. Good luck.